Okay, hi everyone. I'm Sophia Rue. I recently graduated from the University of New Haven with my bachelor's in biology, and I'm sorry I cannot be there in person today. I'm currently in South Jersey with the oysters instead, but today I'll be talking about my undergraduate thesis, investigating the correlation between temperature and Homarus americanus population dynamics from Connecticut to Maine, 2019. So, as climate change is altering marine systems, increasing ocean temperatures could lead to shifts in species geographic ranges, as well as changes in species composition. And since some of the greatest increases in temperature are occurring right here along the northeastern continental shelf, it is important to collect data that can help us understand what is occurring across both space and time. And so I chose to use trawl surveys from Connecticut all the way up through Maine at these separate trawl surveys from the states to see if I could combine these different long-term surveys together and see if I could create a cohesive picture amongst them all. And so I got access to all the trawl surveys from CT Deep, URI Graduate School of Oceanography, Massachusetts DMF, and then Maine DMR. And then I transferred all of them into Excel sheets to try to get everything as uniform as possible. And then at that point, I characterized each state into different zones based on the trawl survey maps that are provided by each state. And then at that point, I split them all both into the spring and fall time periods, then averaged all the species counts and weights to one tow per season per zone. And then for the species specifically, I chose a subset of 7 species focused based on literature review and categorized them into 2 different sections, with the warm water study species being the window pane flounder, summer flounder, and the spider crab. And then the cold water species I had is the Jonah crabs, winter flounder, rock crabs, and then I had a specific focus on the American lobster. And for a lot of this, I use GIS to help kind of show the locations of the zones. So the map you're seeing here is a map I created based on the zones that I split everything into, with the A zones being the inshore and the B zones being the offshore for both Massachusetts and Maine. So when I was creating this map, I used everything here to put my data into the zones. So all of the lobster counts you'll see and everything was placed from my Excel sheets and then joined to the zones and then set up based on a time period. So while looking at all of the data and analyzing it, my 2 research questions were, is there a correlation between changes in temperature and colder water versus warm water species abundances? And then also, are there any trends seen between temperature and lobster population size and distribution? So to start off with the temperature data for the fall surface temperatures, I compared the lowest zone that I had, which was Connecticut Zone 1, and then Maine Zone 4B, which isn't the highest one, but Maine Zone 5B didn't have as many data points as 4B, which is why I chose that instead. But you can kind of see here with this graph, I have it separated into the red zones being temperatures that lobsters tend to avoid, with below 5 degrees Celsius and then above 20.5 degrees Celsius. And then that green box is the optimal range between 12 and 18 degrees Celsius. And so, as you can see, like the average temperatures are increasing in both Connecticut and Maine, but they're kind of increasing in different ways because in Connecticut, those temperatures are increasing up into areas of the avoidance temperatures where it could cause stress, whereas in that Maine zone 4B, they're increasing up into that green zone or that optimal range. You're seeing the same thing with the fall bottom temperatures, both in Connecticut and Maine. Still, they're showing an average increase in temperature, but once again, the Connecticut ones are reaching up into that red point, and the Maine ones are instead reaching into that green optimal zone. So then, compared to those temperatures, I set this all into GIS amongst the time zones. So you can see that this will show average lobster count per tow per zone from 2019 in the fall time period, with the darker reds being higher counts and the lighter whites and yellows being less abundance. And so playing this here, you'll see that as time moves on, you're seeing the northern regions up in Maine turn to a darker red or a darker orange. And then those southern regions and down in Connecticut especially, you're kind of seeing it go completely white or to light yellow. And then with those lobster counts, as I mentioned before, I looked at species weights. I looked at species weights for warm water and cold water compared to counts because some of the trawl surveys have these spider crabs specifically just in weight, not in counts, which is why I chose to go in that direction. But early on in Connecticut, you can see that the cold water species are higher than the warm water species, and then that kind of shifts. Same thing with Rhode Island, you're having those warmer water species take over from those colder water species, which is kind of happening in these transitional points where the cold water and warmer water species are meeting in the lower zones, which then you can see switching over into Massachusetts 1A, you still have your warmer water species. Then in 5A, that upper zone in Massachusetts, it switches to the cold water species and just an overall higher abundance of species in general. You see the same trend in Maine, New Hampshire zones 4A and 4B, which are those upper zones. You can see that the colder water weights are significantly higher and the overall abundance of species is greater. In later years, though, you are starting to see a decrease in those colder water species weights. And so overall, the lobster population had a southern decline in the Connecticut region and a northern increase in Maine from 2000 to 2019, while the temperature increased in both sections. But like I said before, that temperature increase wasn't necessarily the same because that southern end increase is reaching points past the lobster's thermal tolerance, where the increase in northern Maine is reaching points past into the optimal range instead. Part of the data I have for my thesis, and I'm still kind of continuing to work through it because I think there are so many pieces in this data set that can be pulled out and told and used into different stories and different ways to show this data. But so far, I started adding from 2019 to 2024 for the Maine region specifically, but I'm also planning to split from just zones A and B to maybe zones A through D to see if looking in a smaller difference can show a like incremental change. I also am going to alter the additional species used to see if I increase my subset, if that kind of shows a different picture with the cold water and warmer water species weights. And then I also have the NOAA trawl survey data that I could compare all of this to. But this figure on the right is showing zone 1, zone 3, and zone 5 highlighted by those yellow stars, which is the areas I'm going to be talking about for the updates I've started to make in the next few slides. So this is one of the first updates here. At the top, it's showing spring and fall surface temperatures from 2000 to 2024 in those main zones. And this figure is set up similarly to the one I showed earlier, with the green zones being the optimal temperatures, where the red zones are the avoid temperatures. You can see that for the spring surface temperatures, all of the zones are showing an average increase based on the slope of the trend line. And here, all of them are kind of increasing at a similar rate, and they all have a similar average temperature. And then in that bottom section, the fall surface temperatures, you can see that all of them are also increasing based on the slope of the trend line, and all of them are starting to reach up into that green optimal zone by 2024. Here, though, zones 1A and 1B are increasing at a faster rate, and in the past 5 years, zones 1A and 1B have the warmest average temperatures, whereas zones 5A and 5B have the coldest average temperatures. Then in the top here, you're seeing these spring temperatures. So all of these zones are once again increasing, with 1A and 1B increasing at the greatest rate. But here instead, you have zone 5A and 5B with the greatest average temperature in the past 5 years. Then on that bottom, you're seeing the spring lobster counts. So for the lobster counts, zones 5A is showing the largest increase, which is aligned with that increasing bottom temperatures. And then you can also see that when zone 1A starts reaching the points out of the red zone, that's when the count starts to begin to increase. Zone 3A here in the black is also following a similar pattern to temperature. And then you can even see that those B zones are starting to have higher lobster abundances in the later years when those B temperatures are reaching out of the red zone and even when the A zone counts start to decrease. And lastly, here we have the fall bottom temperatures. The fall bottom temperatures, once again, for all the zones show an increase in the average temperatures. And here, the average temperature in zone 3A is the greatest, and the average bottom temperatures in zone 3B and 5B are significantly warmer than 1B, as you can see on the right here. For lobster counts, as zone 1A reaches farther into the green zone, that count also starts to increase, but you don't see as much of an increase in zone 1B over here, which is the coolest temperature. But all zones for lobster counts, as you can see along with the temperatures, follow a similar pattern. So I know that was a lot of data just in those slides. So I kind of tried to create a picture to sum it all together of why to show that how the picture in Maine looks a little bit different from Connecticut, Rhode Island, Massachusetts because of the complexity of the Gulf of Maine, which is why it could be important to take the whole situation into account here. For the fall zones, 1A and 1B had the greatest difference between the bottom and surface temperatures, which could be attributed to the smaller tidal fluctuations here, creating a more stratified environment where the bottom temperatures tend to stay cooler and the surface temperatures tend to stay warmer, which could then affect the lobster counts at the bottom. And on the other hand, 5A and 5B, which experience greater tidal fluctuations, leading to a more mixed water column, which could increase the temperature of the bottom water and decrease the temperature of the surface water when the two masses are mixing, which could then explain why those differences are happening in the lobster counts up in that zone 5 region. Zone 3 sits right in the middle of them, both geographically and numerically, here especially in the spring, with the lobster abundances on highest average being in zone 3. And even when those 3A abundances dip, the 3B abundances start to increase in turn with them, with those warmest average surface temperatures in the past 5 years being in the zone 3 zone, and even them having similar bottom temperatures to zone B. And so this is just kind of the start of my new ideas with this trend going in with this data. So I'm really excited to kind of continue working on it and see what else I can pull out of the data set. But I wanted to thank all of the people that helped me get access to the data, that helped fill my data requests. I really appreciate all of their help with this through my senior thesis. And I also want to thank my advisor, Dr. Simyao, and then finally Chris, and Andrew for introducing me into the lobster world. Thank you so much. Any questions?
Thank you very much, Sophia.
Thank you.
Some time for questions.
Hi, Sophia. It's Andy.
Hi.
You did a great job.
Thank you.
Really excited to see how you've taken this and run with it. You said that you're going to maybe or potentially use the NOAA data to expand what you're doing. Are you going to treat those data the same? Do you have any anticipations on what you might see, or do you have any? What are your plans for using those data?
I mainly was thinking of trying to use it to compare the sets, so it's kind of seeing if you're having similar things go on with the state trawl surveys and similar things going on with the NOAA data that's kind of fluent throughout the state. So I wanted to see if even all of the separate locations would be similar when it's just one trawl survey along. So I was going to treat it all the same and then compare the two different data sets.